Section 7.11 Ligand Chirality. Achiral ligands may bind to a metal, leading to a chiral complex. How is that possible? Well, let's look at this example. These two structures, they look alike. They are mirror images to each other. But you cannot superimpose this structure on this one or vice versa. We say they are non-superimposable on each other. These two structures are enantiomers to each other. So now let's make it simpler. Let's say this is just planar, all right? And then we can clearly see in this structure, there's no S1, improper rotation symmetry element. S1 is equivalent to a symmetry plane, and there's no symmetry plane. You can check, if there's a symmetry plane here. No, because this is pointing above, this is pointing down. And then is there a symmetry plane here? No. Again, because this is pointing up, this is pointing down. So there's no symmetry plane. And also, there's no center of symmetry. There's no inversion center. So if you do an inversion with respect to this transition metal, so this wedge should become hash here, but both are wedges, so there's no inversion center. There's no S2 improper symmetry element in this structure. And of course, there's no S3, there's no S4, there's no S5. Therefore, we say this structure is a chiral structure. It has a mirror image that cannot be superimposed on itself. Now let's look at this ligand. This ligand is simply substituted ethylene diamine, right? This is ethylene diamine or 1,2-diaminoethane, and then it's just N prime dimethyl substituted ethylene diamine. Now let's look at two more structures. Now let's look at this structure. Well, it seems to be very similar to the above enantiomer structures, but in this case, you see wedge, 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 wedge. In this case, there is a symmetry plane. Okay, there is a symmetry plane. So you can just cut this structure here. All right, and then you can see this structure does contain a planar symmetry element, and sigma is equivalent to S1, improper rotation symmetry element. So it does have S1 symmetry element. Therefore, this structure is achiral. Now let's look at this structure. Well, this structure is also achiral because it contains a center of symmetry. And let's do this inversion operation. This wedge will become this hash line, and this wedge will become this hash line. So this structure does contain a center of symmetry, and that's equivalent to S2, improper rotation symmetry elements. Therefore, this structure is also achiral. Its mirror image can be superimposed to this same structure. So in summary, if you are trying to decide if a structure is chiral or achiral, you just need to check if this structure has any improper rotation axis. If it does, well, it's achiral. If it doesn't, this structure is chiral.